So let's get started on this part. You had to identify the vertex, or I guess you had to identify which graph it was. And did it say for you to tell me the vertex and anything else? No, just match it up? God bless you. Okay, so did we match it up okay? With the equations? Everybody good with that? A good way to start is, this is a positive. You can use your transformations. This is going to open up. It's a positive 1. Shift up 3. Okay. This is going to open down. And it moves to the right 4. Use your transformations to help you. This one, shift to the right. It stays right there. It opens up. This one opens down. And if you want to put the plus 3 over here, that's okay. And everybody good with that part? The reason we put it into vertex 1 is so you can graph it using your transformations. And you can find the roots that way, you can find the vertex that way, you can graph this totally without your calculator. Again, you were using the vertex form to do your transformation. Is that a homework? Okay, so take it out. Noah, did you find yours?
No, I don't know if I have it.
Yeah, they're probably in the folder. Here. It's attached to the note page. So it's probably a little harder to spot. Probably if there's two notes. Alright, so let me make this a little bigger. Something small. Everybody okay with this? You guys are pretty good with transformations. Again, just identify as much as you can. Where it's opened up, find the vertex. Right now we're just looking at vertex today. We'll look at the roots as well. But we're looking at your vertex right now. Open up, open down. Here's your complete the squares. Now the first one was a perfect square. Even if you move the 16 to the other side, it would work itself out that way. Even if you didn't realize it at first and you move the 16, for those of you that want to move the 16, if you can do it on one side, that's good. If not, do it on the other side and then just move it over afterwards. I don't want to change your routine. Again, only factor out where the x's are. Don't factor out the constant. The x has to, the coefficient of x squared has, the highest variable has to be 1. Has to be a positive 1. So in number 27, you have to factor out the negative. In 29, you're going to factor out a 4. If any of these trouble anybody, I will be glad to do them with you. So you tell me. Okay, everybody are done with the first 2?
Oh, no.
We'll just give them a minute there. Did I ask you for the intercepts?
Oh.
Did it say on your directions find the intercepts? No? Okay. No. Which one?
27.
Number 27. Okay, so did you factor out a negative 1?
Yeah.
So don't forget, if you did you keep it on one side? Okay, so if you kept it on the other side, this guy said negative 5 over here, right? Plus something. So now when you do this, this is going to factor to, you factored out your negative 1. This is a positive. When you distribute this, this is a negative 1. So you're going to have to put a negative 1 over here. So this becomes negative 6 by itself. When you move to the other side, it will become a plus 6. Don't forget, once you factor something out, you have to distribute it to get it out of the parentheses. Okay?
Move it down.
Move it down this way. Okay. So you guys just went as far as finding the equation? It didn't say do any of this? Copying it out. graphs using vertex, intercepts, and sketch. Intercepts were in there. I'm just going to choose to increase over that part. We'll do that today. Questions? Talk to me if you have any questions. I'll be glad to do this out. This is kind of like the equation of a line. When you have your two x's here, you know, like your equation of the line y equals mx plus b. That b guy is your y-intercept. Same thing here. That is your y-intercept. Yeah.
For 33, why is it 6? Why is it plus 16?
Okay, 33. Did you keep your 11 here or move it over? Okay, so we're going to start here.
Plus
Okay, so we're going to do it this way. So we're going to take half of this and square it. This becomes 16. I add 16 here. So this becomes 5, right? When I move the 5 over, it becomes a negative 5. Don't forget, you got to move it back over here. This will set up your vertex point. So 16 is 4 squared. After you find half of b, just go like this and square whatever's there, put it here, and wherever else you put it. So this is going to open up. It's positive. The vertex comes out the opposite way. There's your transformation to the left 4, shift down 5. Now the thing is, when you're here, when you guys are at this point right here, this is how you did your complete the square last year. You did it on the other side, right? The reason you should do it that way is if you're looking for the roots. So when you find your roots, if this is not factorable, I don't have factors of 11 that add up to 8, right? So I'd have to do the quadratic formula. But if you complete the square and you're right here, this is how you find your roots. You take the square root. You get a plus or minus radical 5. You subtract the 4. Isn't this what you get also when you do your quadratic formula? It comes in that same format. That's the reason why some teachers teach it on the other side, when you're solving your roots. If you're looking for your vertex form, we generally keep it on one side, but it's not a problem. All you have to do is move it back over. So I don't care which way you want to do it. As soon as you do that, as soon as we go to this next step today, just find your zeros while you're there, while you're here, before you even move it back over. From all of this, we'll be able to graph this entire formula, this entire quadratic, without using our calculator. Because we can put it in your vertex form. We can find your vertex. Where's my vertex? Negative 4, 5. So here I am at negative 4, negative 5. It's going to open up. It's going to cross the axis here. So figure radical 5 is close to radical 4. It's a little bit more than 2. So if I'm negative 4 plus 2, I'm still on this side. So it's going to go like this. I use my intercepts to tell me, is it crossing here? Is it y? Where's this going? Also, this is your y-intercept right there, 11. So this is going to cross way up here at the 11. And I'll be able to graph everything from this. I know where my zeros are. I know where my y-intercept is. I know where my vertex is. I know where it opens up. You're also going to see a better feeling for when we do this, what this A does. This A is also where your stretch or your shrink is. So it kind of leaves that separate, so it kind of catches your eye. Oops, I got to shrink, I got to stretch. Good so far? Okay. Today, hopefully, it will kind of all tie together why you actually complete the square. Did we look at this last one, 35? Be careful of this negative 2. you're going to factor out and only factor it out of your x's. Do you see what a disaster if you factored it out of negative 31? Then you got a fraction. Then you got to pull it back in. So at this point, just deal with your x's. Factor this out. Once you find half of negative 8, there's your negative 4, square it. Don't forget to distribute it back out to get it out there. If you're on the other side, that's fine. This negative 2 stays. This tells me it opens down. This tells me it's a vertical stretch. So it's going to be a little narrower than normal. If I do my intercepts, I should kind of be able to pinpoint it. If I go like this, look where my y-intercept is, negative 31, way, way, way down here. So that also kind of gives you an idea of how narrow this graph is. Good. And then this part you have to find the pieces. So let's just take a look at the last part of your work yesterday. Simply, it's attached to that. And it says, find the equation for a parabola whose vertex is at 1, 2, and it passes through the origin. It doesn't tell me if it opens up or if it opens down. So if I sketch this, here's my vertex 1, 2. And I have to pass through the origin. Which way am I opening? Down. And I have to pass through this, so this must be one of my intercepts. So I have a parabola that looks like this. And I have to find this equation. You're going to use your form for the vertex form. And use what's given. This piece here is my h and k. So my h is 1. I plugged it in. Excuse me, and my k is 2. I plugged this in. My only problem is I don't know what my a is. And it's got to be a negative, right? Because I see this opening down. So I have to somehow solve for a. So remember when you guys did mx plus c? And if you had the slope and you had a point, you could plug in the slope and you can plug in the x and y and you can find the b, right? We're going to do the same thing. So now, given this guy, sorry, this is my x and my y, I pass through this point. God bless you. So if I pass through this point, I can substitute in my x and my y. And now I can solve for a. So this can, now we just solve for a. So negative 1 squared is 1. I subtract 2. And a is equal to negative 2. And it makes sense, doesn't it? I'm opening down. The last thing you have to do is just plug it back in to this piece right here. Just like you did with y equals mx plus b. So negative 2, x minus 1 squared plus 2. So I can find my vertex, 1, 2. I can see that it opens down. Good. Use the format for the vertex form. Plug in what you have, and then see what else you need. Sometimes it's kind of simple. Other times it takes a little bit of work. So let's take a look at these couple of homework problems that you had. We'll do these together. Okay. So this gave us so what's given that you can pull off this graph? The vertex. So my vertex is h, k. When I plug in negative 1 in for h, what does this become inside here? Positive 1. Good. They didn't tell me what a is. But what's k? 4. So again, I know I'm opening down, so a must be negative. So it can't be a 1. I can't just automatically put a 1 there. So I can take either one of these points. I like to use the ones that are not negatives because I write so sloppy. Usually I lose my negative signs. So I'm going to take this point over here. You can use either one you like. I'm going to plug a 0 in here. And I'm going to plug a 1 in here. So 1 plus 1 is 2. 2 squared is 4. Subtract the 4. And divide by 4. And then just plug it into this piece right here. And you can put a -1, you don't need your -1. And there's your equation. Good? We'll do one more and then you guys will do the last two. Don't look at my pictures.
We only had.
Oh, you only had, okay, then I'll give you a couple more to do. You only had these two?
No, we had
No,
number
we had
39.
39.
You had 39 and 41? All right, we'll do this together.
We had 39.
Yeah.
37 and 39. Okay. I don't know how that happened. Okay. Let's do this one together, and then I'll have you do 39. So we start out again with your format. This you have to memorize. Okay. And we plug in what's given. So the vertex is a good place to start. The vertex, this is your H, this is your K. So x minus the -2 becomes what? Plus 2. And -1. And we see that it opens up. So luckily we have an xy point here. So we plug in your y. And we plug in your x. 2 squared is 4. Add the 1. And a is 1. And yeah, it opens up, so we know we're on the right track. Just plug it back into your equation. Now, one nice thing you could do to check this, put this in your y1 and see, are those 2 points in your table? And it tells you if you have the right equation. Learn to use your calculator as a good checking point. Works out really well. If I graph this, these 2 points have to appear in my table. Otherwise, I did something wrong. You guys try 30, no. Pretty easy, right? Check it on your calc, make sure it's there. Did you guys on the parabola do anything with a focus and a directrix? You did.
We did, but I didn't learn it. You know, like, you know what I mean? Like, he taught us, but I didn't learn it.
Oh, I do mine so different.
I remember that there's
What
like
about,
line,
she did it like
it's
twice,
point,
and one of them was really hard, and then I
like that.
that was hard. Another question on there.
We'll be doing that soon, but I do mine very different.
It was one of the questions on the common core reasons, I think, but.
They had focus and directrix?
Yeah.
Wow, very good.
All of them some formulas.
There is a formula for it, but don't memorize those formulas. It's easier just to look at the graph and figure it out.
Our church was put in like,
Oh. Mr. DiCaprio? Do you use the video from this? Really? Okay, so let's take a look at this. Oh, that's where that name is coming from. Her?
I love your violet. Why? You're also.
Okay, so did we come up with this for number 39? Check your answers, guys. Did we come up with this for 39?
Yes.
Good. Okay. Now, today, we're going to tie this all back together. And okay, so we need to graph this thing. And we need to sketch it. We need to find the zeros. We need to find the intercepts. We need to tell where it's increasing, decreasing. Without a calculator. Can we do this from this? Just like it is. Can you tell me your vertex? You probably could. Don't you know your axis of symmetry, right? X equals negative b over 2a. We could do that. But we don't do that here. What could we do instead? Complete the square. And we're going to put this in your vertex form. We're going to complete the square. Okay, so is it okay if I do it all on one side, or do you want to do it on? You come accustomed to that. Very good. Okay, and you don't have to do that. You can put it to the other side. I'll do it both ways. So we're going to leave this part together. I also have a plus 9 out here, so I'm going to subtract something. If you did it to the other side, I don't want to confuse anybody, but it would look like this. Okay, so kind of similar, right? What's half of negative 4? Negative 2. I like to do the negative in there, this way we get the minus. What's 2 squared? 4. So I'm going to add 4, I'm going to subtract 4. Here I'm going to do the same thing, if you did it here. I'm going to add 4 here, I'm going to add 4 here. So I combine these, and I get a plus 5. I combine these, and I get a negative 5. So I'm going to add my 5. Okay. So this is our equation. Let's talk about this. What's our vertex? 2, 5. Which way is it going to open? It's going to open up. So my sketch is going to say 2, 5. And it's going to open up. Do I have real roots? No? I'm going to have imaginary roots on this. All we have to do is just say no real roots. So now, let's talk about the rest of this. This is my sketch. A lot of you don't sketch. Make sure you give me a sketch. Sketch, we'll find your vertex. We did. Find your axis of symmetry. What is your axis of symmetry? X equals h. So x equals 2. It cuts right through your vertex, right through the x value. If I bring it all the way down here, doesn't it cross my x-axis right here? So x equals 2. X equals h is your formula. Good. Okay, find my exact zeros. Those are my intercepts. And I got to also find my y. Let's find my y-intercept right now. Look how easy your y-intercept is. Your y-intercept is when x is 0. Just do this. 0, 0. So y is equal to 0 squared minus 0 plus 9. Don't forget to show this to me algebraically. And doesn't this kind of make sense? If this is here at the 2, 5, and I cross up there, wouldn't that be about 9 somewhere? It has to make sense. If you find your intercept to be 0, 9, and your graph isn't going anywhere near it, go back and look at where you graphed it or how you did your intercept, because they all should fit together. Now your x-intercept, very nice. We'll take this one right here. Or if you took yours, we'll put this, we'll set this like this. We'll set this equal to 0. If you guys did it this way, you are right here at this one. We'll subtract 5. And this is how we'll solve. Normally you put the quadratic formula in here. But we already have this in this form. We take the square root. Remember, you get a plus or minus when you take the square root. Now in a little while, we'll worry about the I, but not right now. And then we would add 2 to both sides. If this was, say, radical 5, we would add 2 to both sides. If it was a plain old radical 5, then it would say this, plus or minus radical 5, if it was. But because this is imaginary, we will say no real roots. The only time we worry about the imaginary is when we get to that part. We only do it for a short time. The rest of the time we just say no real roots. Okay? So now we've got a state where it's increasing, decreasing. I'm looking for the value of y to be decreasing and then turn and increase. But I use my x interval. So as x comes from negative infinity to this point right here, 2, what is the value of y doing? Decreasing. So from negative infinity to 2, it's decreasing. We always use soft brackets around your increasing, decreasing. Then from 2, as x moves to the right, from 2 to infinity, what's the value of y doing? Increasing. So from 2 to infinity, it's increasing. What's my domain for this guy? For this parabola? All real numbers. So shouldn't my increasing, decreasing cover my whole domain, right? Which it does. What's my range? Five to infinity. It doesn't start till here. There's nothing under here. So be careful. Hard bracket, 5 to infinity. Hard bracket if you include it, soft bracket if it's not included. Increasing, decreasing always goes with the soft bracket, as well as infinity signs. They always go soft bracket. Because technically, if you give me a number, you can always find one more. Good? Okay, so you have the other 3 for homework.